Hi everyone, thanks for dropping by my YouTube channel today and checking out this video on a QuadraFire 2301844 pellet stove controller. This is an older model for a pellet stove that has a variable speed motor on it, a 3-speed motor. They call it a 3-speed control board. And it's an older unit. It's a precursor to the newer clear box 3-speed board units that look like this. It's a precursor to that, so it's got all the same capabilities, but it's an older version of that. They probably did not make many of these, so they might be a little difficult to see out in the wild or to have on your actual stove. So I've had this one on my pellet stove. It's a Castile, and it's been on now for about 25 minutes. So the exhaust fan timer has elapsed and it is fairly quiet. I'm also not calling for heat, so my call for heat thermostat is not on. I'm simulating a room temperature of 58 degrees Fahrenheit, and we can see on this meter that we're at 2.6 volts AC. That meter will indicate the voltage being driven by the controller to power the heater element. That's all done actually through a relay which is on the circuit board here, a little black box. That black box controls the heater element, and they use a mechanical relay there because the current draw on the heater element is quite high. So as you can see by the controller itself, which is located here, I've got one blinking yellow light, which means that the timer has elapsed and it's in standby mode waiting for the thermostat to generate the call for heat signal. I will say, as I noted before, that the timer for the 20-minute initialization has elapsed, so the fan ran for 20 plus minutes while that timer was on, and now it has come to an end. So everything is quiet here. So there's a couple things I'll talk about here while I have the controller still not running. There's on the edge of the controller at the top, or on the top here, we have a red LED and we have a green LED. Just watch, I'll probably call that a yellow LED a bunch of times, but that's me. The red LED and green LED are visible from the outside of the controller. On some other brands or models of controller, you'll see the LEDs are back here, but in this case they're at the top or at the side of the controller. So there's two reasons for these indicators. The yellow one, or the green one, is actually will come on at about 168 degrees Fahrenheit. The red one will come on at about 570 degrees Fahrenheit. They basically are timing points and temperature reading points to allow the controller to turn on or off some of the capabilities of the controller as the fire temperature ramps up. So I'll go ahead next and I'll turn on the call for heat. That is basically turning the thermostat on. At that same time, we'll also start adjusting the temperature of the fire, and we'll see what happens to the heater element voltage as the temperature rises and we go through the different set points as indicated by the red and the green LED. So let me go ahead and do that. We won't see it in the video, but behind here on this stove is where the call for heat light is on. That's sometimes you see that on the rear of the furnaces, but on this stove it's on the back here, so it's not really visible to the user. So let me turn that on and we'll hear the exhaust fan come on. And here we go. So the exhaust fan comes on. At the same time, we see that the heater element voltage has jumped up to 120 volts AC. So basically now the controller is providing electricity or current to the heater element, and that is starting to warm up and eventually it will glow red, and that will cause the pellets just above it in the fire pot to ignite. At the same time, and unfortunately we cannot see it here on this controller, we don't see any difference here, we still see just a yellow blinking light. The auger is spinning, and the auger will spin for approximately 2 minutes. I've pre-tested that. To drop a load of pellets into the fire pit so that the element as it heats up has something to ignite. That would be the case if you burnt everything off during the previous cycles and there's no fresh pellets in the fire pit. as the heater element heats up, you drop in some pellets, and that will cause the pellets to ignite. That auger drive goes on for approximately 2 minutes, and with that, after the 2 minutes has elapsed, we leave it up for the igniter to try to ignite those. So I'm going to go ahead now and ramp up the temperature, and as I noted, 168 degrees Fahrenheit. When I get to 168 up here, we'll see the yellow light or the green indicator light up here come on. So let me go ahead and do that. So 115, 155, 173, and we do see the green light up here come on. So that would also cause the auger to stop driving for now. So we're basically at temperature. We don't want to overload the pellet, the fire pit with pellets and swamp it out. So the auger is no longer driving. I can confirm that because I've monitored my auger and I know that that's happening. So right now we're no longer driving pellets, but we are still heating the element up. So the plan here is to continue heating the element until the fire catches and we're roaring above 570 degrees Fahrenheit. So I'll go ahead and increase the temperature some more, and I'll reach that 570 degree Fahrenheit point. I'm at 250, 300, and when we reach the 570 set point, we'll note that the red light up here will come on. So let's go 530, 40, 50, 563, and we're still not on. So let me crank it up slowly here. And we've just come on. We'll hear the relay click shortly. There it is. And at the same time, we'll note that the heater element is no longer being driven with current and voltage. So in the state that we're in now, we are at 579 degrees Fahrenheit. We can go higher and nothing's going to change. That's it now for the changes. We're at 570 degrees Fahrenheit or higher, and we are no longer driving voltage to the heater element, so it's starting to cool off. That is our power saving mode. Obviously, since we're at a higher temperature, we have a fire going there, and there's no point to try to continue driving a heater element and consuming electricity needlessly. So we have our two lights on up here, the two outside indicator lights, and we have our call for heat light on. So I'll go ahead and shut off the call for heat light, or turn off the thermostat. And not very much happens here, other than, again, we can't see it, but the auger is no longer driving pellets into the fire pit. So whatever pellet load is in the fire right now is going to burn itself away, and it's slowly going to smolder away until the fire dies out completely. So we've turned off the thermostat, or the room temperature is too high and is turning off the thermostat. Either way, we are no longer driving pellets. But we still have a hot fire, right? What's actually happening is as the fire burns, pellets starts diminishing, we have a smaller fire, and the temperature will drop and drop and drop, to the point where the room might start cooling again. And if it cools again, then the thermostat will kick back on, and the auger drive will come back and start feeding more pellets into the fire, and the temperature of the fire will increase again. Increase, which will cause heat for the room, and the thermostat will eventually shut itself off. Notice though that because we're above the 500 degrees Fahrenheit set point, the heater element does not come on. So we can turn the heater up, or we can call for thermostat to be on and off, but the heater element does not shut itself off or come back on. It is off and it stays off. So if we leave it in this mode right now, not calling for heat, we are no longer driving pellets into the fire pit, and if we leave it this way for an extended duration of time, the fire will extinguish, the fan will run itself out due to the timer going off, and the stove will go back to idle mode where it's waiting for the thermostat to call for heat once again. So I want to say on this pellet stove controller, everything is functional, everything looks good. The last thing I'm going to do here for the quick check is an open thermocouple check. That I did not show at the beginning of the video, which I wish I had, was before turning on the heat, if our thermocouple was not connected, then we would see both of these lights be on at room temperature. So we're at room temperature. Let me crank that down here. We're at room temperature, let's say 40 degrees Fahrenheit or a little warmer, right? 75 degrees Fahrenheit. We're at room temperature, and we're not calling for heat. And the exhaust fan cycle, timer cycle, has extinguished itself, has elapsed. If we did not have a thermocouple connected to our stove, notice what happens here. The two lights have come on. Let me go back to turning on the thermocouple again. Notice that they're off. There's no lights. We're not calling for heat. We're at 74 degrees Fahrenheit, and we're not driving the heater element. If I disconnect the thermocouple, the two lights up here come on, indicating to us that the thermocouple is open and needs to be replaced. So that's a quick check for your own stove with this model of controller. If the two lights are on, then and you're at room temperature, it's quite probable that your thermocouple is open or not functioning. So that's something to check for. Otherwise, if your thermocouple is on, even though you're measuring room temperature, notice that the two lights are off. So everybody, I want to thank you very much for sitting through and watching this video. I appreciate that very much. I hope that you'll take the time to give it a thumbs up on YouTube and subscribe to my channel. I appreciate that very much. For those of you who are interested, this controller is for sale. I just refurbished it. It's fully functional. I replaced a couple of failed components on it. It is fully functional, and it's a very clean, nice looking controller. Check the video comments down below for my contact information. And if this controller is still available for sale, I'll let you know, and we can proceed from there if you're interested in buying it. Thanks everybody. Have a good day.